next is the nomenclature of ethers. Now, when we are considering the nomenclature of ethers, there are two systems: common name system and LPC name system. As you know that ethers are the compound in which the oxygen is attached to same or different alkyl or aryl groups, and therefore when we are considering the common name system to give the names to the ether, so in that case you have to write the names of the alkyl groups which are attached to the oxygen in the alphabetical order, and then you have to write down the word ether. In case of same type of alkyl groups are attached to the oxygen, in that case you have to use the prefix di. In this way we can give the common names to the ethers. For example, CH3OCH3. What is the common name? There are two methyl groups are attached to the oxygen, and therefore both are the same groups, and there are two groups, and therefore we are writing di-methyl ether. You have to write the name of the alkyl groups in the alphabetical order, and then you have to write down the word ether. But both the alkyl groups are same in that case, and therefore we are writing methyl, and before methyl we are writing the di, so it will become the dimethyl ether. CH3O, CH2, CH3. Now in that case the two alkyl groups which are attached to the oxygen are different. One will be ethyl and second will be methyl. So in that case you have to follow the alphabetical order. Alphabetically ethyl comes first, and therefore you have to write first ethyl, then methyl, and then the word ether. So what is the name becomes ethyl methyl ether. Then CH3O, CH2, CH2, CH3. There are also two different alkyl groups. One will be methyl and second will be propyl. But to this propyl group, oxygen is attached to the terminal carbon atom, so it will become N-propyl. Now in the alphabetical order, methyl comes first, so it will become methyl N-propyl ether. Methyl N-propyl ether. In that case, first will be a phenyl group and second will be a methyl group, so it will become methyl phenyl ether, or it is also called the anisole. Then in this example, one group is the phenyl group and second will be N-propyl group, so it will becomes the phenyl N-propyl ether. So in this compound there is no common name. So in this way we can give the common names to ethers. Now how to give the IUPAC names to these ethers? So you have to follow the rules of IUPAC. So according to the IUPAC, the ethers are called the alkoxyalkane. These are called the alkoxyalkane, and in that case the alkane you have to consider. Now in the ethers there are two alkyl groups, so the larger alkyl groups is considered as a alkane, and the smaller alkyl groups you have to consider as a alkoxy group, and then you have to give the name, that is alkoxyalkane. So in that case the position we are representing by the number 1, such type 1 or 2, by the such type of numbering we can give the position. So first example, CH3OCH3. So in that case both the groups are same, so first you have to consider one group is the methoxy, so it will become the methoxy methane. It will become the methoxy methane. In that case CH3 group and ethyl group, methyl group and ethyl group, so this will be a larger group, so it will become the alkane, so it will become ethane, and this will form the methoxy, so it is methoxy ethane. Then in that case one methyl group and another is the propyl group, so N-propyl group, because the oxygen is attached to the terminal carbon atom, so it will becomes one methoxy, because to first carbon atom there will be attachment of methoxy group, so it will become one methoxy propane, because the larger alkyl group we have to consider it as a parent alkene, so it will become one methoxy, 1 2 3, so one methoxy propane. In that case the one will be a phenyl group and second will be a methyl group, so this will be a larger group, and therefore we have to consider it as a parent. Then it is benzene, so it is methoxy benzene. It is methoxy benzene. Now in that case there will be one propyl group and another will be a phenyl group. Now 1, 2, 3. So at first position there will be a oxygen is attached, and therefore it will becomes 1 propoxybenzene, 1 propoxybenzene, because first carbon atom there will propoxy group is attached, so it will becomes 1 propoxybenzene. Now this is the cyclic ether. There are 4 carbon CH2 groups are attached to carbons, so there will be 4 carbon atoms. Now in that case you have to give the numbering. So you have to start the numbering from the substituent carbon atom, and therefore we are giving the numbering from that carbon atom 1, 2, 3, 4. Now in that case you have to consider the 2 alkyl groups, that is the methyl groups are attached to the carbon number 1, and at second carbon atom there will be a OCH3 group, that is the 2-methoxy. So it will become the 2-methoxy 1,1-dimethyl, 2-ethoxy 1,1-dimethyl, and this is the cyclic alkene. Parent alkene is the cyclic alkene which contains the 4 carbon atom, and therefore it will become the cyclobutane. So what is the name becomes 2-methoxy, because at second carbon atom methoxy group is attached, 2-methoxy 1,1-dimethyl cyclobutane. So that is the IUPAC names of the